What's up, gang? Welcome back to Project 1UZ. Pretty ordinary weather in Bundaberg today, so really not going to work in the car because it's horrible out here. But I'm drawing up all the CAD stuff now for the new manifold going on the Sora for the intercooler, so thought I'd run through all of that with you. So let's go check it out. So here we have it. The program I'm using for this is called VCarve Pro. It's a 2.5D CAD software. So the difference between 2.5D and 3D CAD is basically that 2.5D, we're only dealing with one single plane, whereas 3D, we've got all three planes to basically craft all our geometry from. But for the purposes of 3-axis CNC machining, it's kind of a little bit over the top. So yeah, I just prefer to use VCarve just for the simple 3-axis CNC machining stuff. Alright, so with all these bits all over the screen here, it probably looks confusing, but it's a lot simpler than it really looks. So on the very perimeter here, we've got, that's the outside size of the box. All the stuff that just popped up in pink, so that's our ports that go through to the stock 1UZ lower intake manifold. So we've got all of them there with the mounting holes that go around the outside. So that's all pretty straightforward. You can see these little bits on the side here. They're part of a flange to house the intercooler plate itself. It'll make more sense a little bit after. And this bit here is the M90 supercharger layout. So we've got our supercharger outlet here, bypass valve port, a couple other miscellaneous ports on the bottom of the M90, and all the little holes around the outside here are all the mounting holes for the supercharger. So with all that being said, we can generate a 3D preview of what it's roughly going to look like. I've already created all the tool paths, so it's going to quickly pretend like it's cutting it out right now, and you'll see the basic layout of it. And that's it. So that's essentially what the box is going to look like. As you can see, one big void in the middle. Got our ports down the bottom, and it's a T-shaped box. So the reason behind the T-shape is basically that we're limited by the dimensions of the stock 1UZ fuel rails. So either side of the manifold, you've got the fuel pressure regulator and fuel dampener, and pretty much you've got to be 218 millimeters in width to be able to make it within those two. So with that being said, that's what this is. So it's 218 millimeters there to there, and then as we go up, we step across, and that's basically to accommodate for the width of the M90 supercharger. So the intercooler plate will go in here, and then the top plate on top, and then supercharger mounts to that. So it'll be pretty close to being level with the sides there. So as you can see, there's a big void there. It's not 100% accurate, this model, of what it'll look like in real life, because we're limited by the 3D modeling of the 2.5D software. Basically, there's going to be a flange that goes across here as well on both the front and the back, but just because of how it cuts the tool paths out in this, it sort of makes it incredibly difficult to show that in here. So for that reason, I decided to transport it all across into Fusion 360, which is a full 3D CAD modeling software by Autodesk. So this is it. So as you can see, we've got our flange across the back there now, and across the front as well. That basically gives us a nice level surface to mount our intercooler flange plate to, basically. Our intercooler core will be in this void in the center here, in that large box section in the bottom. So yeah, I hope that gives you a bit of a better idea of what it's actually supposed to look like. So with that being said, we'll have a look at the intercooler plate, which is this one here. So it's basically just a bit of 20 millimeter thick aluminium plate. On the inside here, you can see this recess that's machined down 10 millimeters deep, which gives us a nice little void in there. And then this section cut out all the way in the center. So that center bit there is actually the full dimensions of the intercooler core that we'll be welding into it. So once we cut the end tanks off of the water intercooler, it'll be recessed up into here, so it's flush with that top edge of that cutout right along there. It'll then be fully welded all the way along with the TIG, which leaves us with, the intercooler core mounted in there and this void here. If you're wondering about what the point of the void is, basically this will sit in the top of the manifold box, and then there'll be a 10mm top plate that goes on top of this as well. That'll have all the layout for the supercharger to bolt to it. So as the air is blowing through the supercharger, we're spinning it so fast that obviously we're generating a lot of high intake temps. So I'd like to be able to capture that data just for research and development purposes, basically. So with the supercharger mounted on top of here, it'll blow into this little void here before it goes into the intercooler there. I'm hoping to run a intake air temperature sensor right here. Because of the layout of the M90 supercharger, this corner of the manifold's kind of just open space. So from the top there, we'll be able to vertically pop a sensor into there, and it should be able to measure the temperature of the air in here pre-intercooler. So that'll be pretty cool. That being said, there's actually 2 other temperature sensors that are going to be used in with all of this. We will have another one in the bottom side of the box after the intercooler that will be measuring the temperature of the air as it goes into the engine, so we can find out what our efficiency is like there and what the temperature drop is. And the other one I'm looking to capture is the water actually going into the intercooler itself will most likely be fed from the back of the box. There'll be basically a hose connection here. It'll probably be like speed flow line or something like that. It comes off the intercooler that will run to the back through a bulkheading fitting there. So we'll have water in and out. Then we will have a temperature sensor measuring the intercooler's coolant temperature, basically. That way we can find out if for some reason that we ever get to the point that we're heat soaking the water going through the exchanger. More information the better, basically. So from there we've got one last drawing to have a look at, which is just the raw dimensions. So this is the side profile of the manifold. So looking at it, well, realistically from the front or the back, and it gives us our basic dimensions. So as I said earlier, we've got 218mm in width in this lower section of the box, and that's to accommodate for the stock 1UZ fuel rails. So with that, we are 150mm tall now, which is about an inch taller than the last manifold. It was only 125. Didn't really want to be much higher than the last one, but it's kind of a necessary evil just because we're running such a thick intercooler core. So with that being said, from this section from the inside of the manifold box on the bottom to the top of the flange here, we've got 110mm. So this plate above it here, which is the intercooler plate, is 20mm thick, and we've got that 10mm recess into it, which means that the intercooler core itself will be recessed up into it 10mm. It's a 100mm core, so with that being said, we'll end up having a 20mm void below that. So as the air goes through the supercharger, blows through the center, it'll go through the core, and then it'll have a pretty tight corner there, I guess, that the air will be going through into the box, and it'll have to travel sideways and then through those ports. And you may be thinking that sounds horrible for a flow perspective. And I mean, it's not great, but realistically, comparing that to the last manifold that I've been using, I had a 40mm box on the top of that manifold. And that sounds like it's a lot better, but realistically, when you look into it, the 6mm steel plate that the supercharger mounts to is recessed into the top of the box, so we can take 6mm off of that 40 straight away. And then the bottom section of it, you don't actually see the 10mm plate goes through the bottom section of that box there. So you're only left with like 24mm of void anyway before the air had to hit the bottom of the box, travel sideways, and then go through the riser tubes that were there. So, I mean, we're obviously not running riser tubes on this either. They just go straight onto the stock lower manifold. But we're kind of in the ballpark, basically, of what the airflow was last time. So it'll be a good comparison of what it was anyway. So, yeah, from there, we'll have our 20mm plate here, and then this one on the top here is another 10mm plate, which is the mounting plate for the supercharger. So if we go back to our 3D model in VCarve, you can imagine that we'll have a gasket rolling through here. That flange will continue through here, and then our intercooler plate will lower into there with our manifold, with our hose connections for water in and out there, and then the top plate will go onto that. Now, I know this box is 150mm tall, but this is actually going to get made out of 10mm plates that are all cut out individually and then TIG welded together. I'd love to be able to make this thing out of 150mm thick billet aluminium, but realistically I've got no idea where I'd source that from, and I'd hate to know how much it'd cost. So yeah, I mean, let alone the amount of wasted material we would have in here if it was to be cut out of one piece of 150 billet. But yeah, that being said, this bottom plate here and many of the other plates, the beauty of cutting them out on the CNC is this plate will be 218mm wide, and there will be a slight recess cut into the outside perimeter of it there. That'll be 10mm wide by probably only about 1mm deep, just to locate each piece as it goes together. So it'll sort of all Lego together, I guess, and it'll make it really, really great to weld together because it'll all just sit into its each little recess and just makes it a real great jig to be able to just keep on welding out. So there will be a lot of welding in this too. As you can see, we've got a lot of joins there. Like each piece, you can imagine, like this will be its own separate piece. The side panels here, that is its own piece, and yeah, all the rest of it. So yeah, there'll be a little bit of fab stuff to go on, but we're prepared for that when it happens. So yeah. If you're interested, drop down in the comments. I've just dummied up the tool paths in here and created them basically so you could see a 3D model. If there's enough people interested, I'll actually do a detailed video and showing about creating the G codes to put into the CNC machine. I've actually got access to 2 different CNC machines. I've got a desktop router, which is a 6040Z, so it's basically capable of cutting 600 by 400mm wide piece of material, and we've actually got a substantially larger machine that'll cut 2.4 meters by 1.2 meters. So that's probably the machine that we'll end up using to cut all the plates out on, just because it's a lot more robust machine, and if we have multiple plates we all want to cut at the same time, then we can just cut them all out of one bigger sheet, which will be pretty cool. So yeah, if you're interested in seeing all that G-code creation and toolpath data, let me know, and I'll make another detailed video on that. So that being said, I hope you've enjoyed the video. Drop us a like if you haven't yet, and if you haven't subscribed, I'd really appreciate it. It really helps with me motivation to keep making these videos. So yeah, I hope you're learning something and you get some enjoyment out of it. So thanks for watching, and I'll catch you on the next video.